Hi, so I say all the time that understanding in mathematics is more important than memorizing. I also say, but not as often, that, well, you should enjoy life, I think. You should also enjoy math because math is part of life. I think that to enjoy math, understanding helps, at least for me. The more I understand math, the more I enjoy it. And what I mean by understand is understand basically why all math facts are true. Let's take the Pythagorean theorem. When I say do you understand the Pythagorean theorem, I mean, do you understand why the Pythagorean theorem is true? So, what I'm trying to do now is understand every math fact I know and just learn more math facts and understand those, and I'm going to help you do the same with this YouTube series. So and the same with physics. One thing we're taught in math and physics is we're taught two definitions of the cross product. I'm sure you know that to which I'm referring. One has to do with a sine of an angle. The other has to do with unit vectors I, j, and k. And we're basically taught that those two expressions for the cross product are equal. I'm going to prove that they're equal, and at least endeavor to do so. So this first video is just a baby step there. So first of all, really we're in 3 dimensions. This is my 3-dimensional space. But for simplicity, I'm going to do 2 dimensions just for this first video. So here's A and B. Now the cross product has a direction, but for this first video, we're just going to simply prove that the magnitudes of the 2 definitions of the cross product are equal. So here's my claim, and here are the 2 definitions of the cross product. All right, so to start out, I enjoy life, I enjoy math, so I just did this video for fun, and I do proofs for fun. So how do I start my proofs? I frequently do them backwards. So I start with what my goal is, and I just basically unpack stuff, or write it in different forms. So instead of A, I write big A like this, I write big B like this. Oh, by the way, theta is just, it would be like the angle between these vectors. I write big B like this, sine theta gets copied. All right, now let's do our cross product. Oh, I'm also assuming I actually need to prove. So anyway, maybe that's for another video, but notice that we're assuming that the cross product and addition satisfy the distributive law. So let's assume that I'll sweep up the dust later, but we're sort of assuming that. So, and then I guess these individual cross products with unit vectors we can just do with the right-hand rule. So we have A1, B1, I cross I, that's 0. A1, B2, I cross J is K, right? Then we have A2, B1, J cross I is negative K. And then these J cross J's cancel. So it came out to this. I wasn't seeing anything fruitful come with this, so I guess it was back to no, I think I was trying to unpack this some more. So this means it's equivalent to. So the left side of the equation gets copied, and then I was thinking, okay, I don't really know what to do, so I'm thinking, okay, let's try something else. Let's do component. Let's just say that I'm measuring, let's say A's angle is alpha, B's angle is beta, both measured counterclockwise from the positive x-axis, and we just stop when we get to the vector. We don't keep winding around. So the left side breaks down to a squared cosine squared alpha plus a squared sine squared alpha. That's just this. And then the b thingies are b squared cosine squared beta plus b squared sine squared beta. And then sine theta, where theta is like the angle between these vectors. Since we're just doing absolute values, I'm just going to say it right like this, the sine of beta minus alpha. All right, the right side, we are going to, okay, so A1 is a cosine alpha, B2 is b sine beta, the k gets copied. All right, A2 is a sine alpha, B1 is b cosine beta, and then the negative k gets copied. Okay, so on our left side, I'm seeing that's equivalent to big A times big B times sine B minus alpha. That's in absolute values. On the right, I'm pulling out the AB, and I'm good with my sum and difference identities for sine and cosine, so I know that the sine is B minus A, so we're done. I hope to continue this little sub-series of videos until we've completely proved the equivalence of the two standard definitions of the cross product in three-dimensional space, and also worked out, how this fits in, that we're assuming that the cross product and addition satisfy the distributive law. Anyway, it's the first attempt. It's the first step on this long journey. Hope to see you in other videos on this topic.